Hi, I'm Jake Russell.
I'm Betty Eifert. I can't do this. And I'm Emma Muchler.
And this is Ned the Neuron. He is a multipolar neuron. Here, the green structure are called dendrites. The purple structure is called the soma. This is the nucleus surrounded by cytoplasm. The orange part here is called the axonal helix. And these balls here is a nerve impulse transferring down the neuron. The blue part here is the axon, and this is the myelin sheath. The areas between the myelin sheath are referred to as the nodes of Ranvier. In this place, you have potassium gates that allow for the transfer of neurons from the extracellular space to the intracellular space, and this speeds up the nerve transmission down the axon. The purple part here are the terminal branches, and the blue parts on the end are terminal buttons. Terminal buttons contain vesicles, which are full of neurotransmitters. The space after the terminal buttons is called the synapse.
All right, so when a nerve impulse starts, it collects a nerve impulse from another dendrite in the terminal button. It releases the neurotransmitters into the dendrite, and then the dendrite takes the neurotransmitter into the nucleus. And this is the soma and this is the nucleus, so it gathers into the nucleus, which is surrounded by the cytoplasm, and the nerve impulse collects in the axon helix. And then once a couple of these collect, the nerve impulse fires down the axon, and as it fires down, it speeds up at these points called the nodes of Ranvier, and the myelin sheath acts as an insulation or a protection, so if it bumps into another axon, it won't rub or anything. So as the nerve impulse goes all the way down, it ends right here. This is the end point of the axon, and it releases into the terminal branches and the terminal buttons. And once it hits the terminal buttons, the vesicles open and release neurotransmitters into the synapse, and then that connects into another dendrite. And there you have it.
And one thing that's cool too is that the myelin sheath here, it's a protective layer, basically like the rubber around a wire to prevent axon to axon contact. But the more you use a specific neuron or set of neurons, the thicker the myelin gets. So like your habits and the things you do most often are the thickest of neurons, with the myelin sheath being the thickest part because it's the ones you use the most. So like if you have a habit and you want to go to like a different habit, and this is totally extra stuff, but you have to use your neurons for like a different habit just as much as your original one. So say you wanted to quit smoking, then you'd have to build a neuron saying, I'm going to chew gum, and use that neuron just as much as you use the one that led you to smoking in order to basically be stronger in that, which I thought was kind of cool. So yep, this was our presentation on Ned the multipolar neuron.